This is lesson 2, grade 9, electric circuits. Alright, in the previous lesson we had a look at how to calculate resistors in parallel as well as resistance in series. Now in this lesson we're going to extend on that, and we're also going to have a look at Ohm's law again. If they tell us that in this circuit we have a voltage or potential difference of 10 volts across the battery for V1, we can calculate the following for question A. Now question A will state, calculate the total effective resistance in the external circuit. If you look closely, you'll see that this circuit has a set of parallel resistors as well as a resistor in series. So we will have to add these two sets. Right, first of all, we're going to calculate the resistance in parallel. Remember, the formula says that 1 over Rp is equal to 1 over the first resistor in parallel plus 1 over the second resistor in parallel. And if we add those two, 1 over Rp will be equal to 3 over 4. Not over 4, over 12, sorry. Right, then we have to get the reciprocal. And if we get the reciprocal, we're sitting with 12 over 3, which is 12 divided by 3, and that will be equal to 4 ohms. So the total resistors in parallel is 4 ohms. Alright, now we just have to add that 4 ohms to the resistor in series, which is 2 ohms, and then we have our total effective resistance in the external circuit. So the total resistance will be the 2 ohms in series plus the 4 ohms we've just calculated. So that will end up being 6 ohms. Now that we have the total external resistance in the circuit, we can use that to calculate A1. Now A1 is the current flowing through in amperes through the circuit at that point. Now, because it's part of the main circuit, we will use the main voltage and the main or the total external resistance to calculate that current. So the main current goes along with the main voltage over the main battery, which goes along with the total external resistance. We will be using Ohm's law for this, so let's do exactly that. Ohm's law states that V is equal to I times R. Now I is our current, which we need to calculate. Our potential difference is V, which is the 10 volts, and our total external resistance was 10, not the 10, the 6 ohms from the previous question. Alright, so then we can just calculate I by saying 10 divided by 6. We divide with 6 on both sides, and that leaves us with I of 10 over 6 amperes. And now that we have the total external resistance, we have the current in amperes flowing through the main circuit, we can use this current to determine some other components in the circuit. For example, V2. Now how will we calculate V2? V2 is a specific voltmeter, and that voltmeter is across the 2 ohm resistor and not any other resistor, and it's not part of the total voltages. Okay, so again we will use Ohm's law, but in this case we will use the current that we've calculated in A1, but we will only multiply that current with the 2 ohm, and then our answer will be in voltage, and this voltage will be the volts only in the V2 voltmeter. Alright, this was lesson 2 in electric circuits. Hope to see you in lesson 3, where we will do some more advanced and more complicated circuits. See you in the next lesson.